Good morning, pre-cal. Today, we're going to go over Unit 11, Day 5 notes, word problems, and they're going to involve a calculator. You will need a graphing calculator on this section of today's assignment. Let's get to it. Looking at example 1, Ariana invested $400 in an account paying an interest rate of 3.8% compounded monthly. Assuming no deposits or withdrawals are made, how much money to the nearest $10 would be in the account after 11 years? You may be thinking to yourself, how are we going to solve this? Well, we're going to need to use a formula, not just any formula, a particular formula. And the formulas that we will be needing to use today in order to solve these problems are these right here. You might want to pause the video, write those down. And then these right here. Once again, pause the video, write them down. I'm going to move on. All right, so now going back to the word problem, you're going to have to look for keywords in the word problem in order to figure out which formula you're going to need to use. So we are compounding monthly. So we're going to use the compound interest formula. I'm going to begin setting this up. So the initial investment was $400 and then 1 plus. Now we're going to create a fraction. You want to go with the rate. The rate is 3.8%. You're going to want to convert that to a decimal, 0.038. Now in the denominator here is going to be the amount of times that we are compounding. Since we are compounding monthly, that would be 12 times that we'll be compounding throughout the year. Next, out here, you're going to have two terms, the amount of times that you're compounding and then the amount of years. And we're going to multiply those two together. Now we are solving for what would be in the account after 11 years, given the data they presented us with. So here we have our initial investment. Here we have the rate. Here we have the amount of times we are compounding. And then up here, exponent compounding times the amount of years. And if we plug this into our calculators directly how you see it here, you'll get the answer. All right, so I plugged it into my calculator exactly how I have written down on my piece of paper. Hit enter, and you should get 607 point something. Now they're wanting us to round today to very odd places. Some of them are kind of weird and might require you to remember, where do I round to there? So for this one, they want us to round to the nearest $10. So I'm going to write down 607. This digit here, the 0, this is the tens place. So this would round up to 610. If we round it up to the nearest $10, your final answer would be 610. Example 2, Landon invested $110 in an account paying an interest rate of 4.1% compounded continuously. That's the key word. So we're going to use compound continuous formula here. Assuming no deposits or withdrawals are made, how much money to the nearest $100 would be in the account after 5 years? So we're going to start with the initial investment. Times, remember we're using that continuous compound formula, E raised to the rate, which is 4.1%, but we're going to convert that to a decimal, 0.041 times the amount of time that we are investing, so 5 years. Now we're going to plug that into our calculator exactly how I see it on my paper there. Hopefully I'll get this to a spot where you can see it there. That doesn't look too bad. So 100. Now E, here's how you're going to find E. You're going to do second and then LN. And now put in the exponent, 0.041. Oops, you know what? I just realized I made a mistake. I put 100 instead of 110. There. Enter. Okay. I got 135.027. Now this is where it's kind of weird. I'm gonna write down 135. They want us to round to the nearest $100. Well, here's the 100 place. And if we rounded to the nearest $100, this would round down to 100. I don't necessarily like the way that they wanted us to round here, but it is what it is, and that's your answer. Example 3, Nathaniel invested $37,000 in an account paying an interest rate of 5.7% compounded daily. So we will be using compound interest formula here. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value to reach $70,900? So if I begin setting this up, I'm going to start with the initial investment. Open parentheses, 1 plus the rate, convert it to a decimal, over the amount of times that we're compounding. Since we're compounding daily, that would be 365 days, raised to the amount of times that we're compounding times how long. Well, they asked us here to find how long is it going to take. So we don't know the time, but we know how much we want it to accrue. We want it to accrue to 70,900. All right, so whenever we go to solve this problem, we have to solve for t. We want to isolate the base here and the exponent. So we have to get rid of this first. In order to do that, divide both sides by 37,000. Now that we have isolated the base and the exponent, we can now convert to logarithmic form. So it's going to be log. Now this is a lot to write out. So I'm just going to note that this portion here would be the base of the logarithm. So log base this of this fraction here is equal to 365 times t. All right, I'm going to go ahead and start plugging a portion of this in my calculator. I'm going to begin plugging this in first. Now, let me show you what you're going to do here. You're going to hit math and then scroll until you find log base. So you're going to hit the math button and scroll until you find log base. Then hit enter. I'm going to open up a set of parentheses here. And remember, this is the base of the logarithm. So 1 plus 0.057 over 365, close parentheses. Now I'm going to scroll to the right, and I'm going to enter this portion in. And then hit enter. All right, so that's what all this equals here, just to give you a visual. 4164, I'm not going to write the entire thing down, is equal to 365 times t. And now we can solve for t by dividing both sides by 365. So in your calculator, just take the full answer here and divide it by 365. So t equals, and then what did they want us to round to? Round to the nearest year. Well, that would be 11.4. So rounding to the nearest year, it's going to take about 11 years. Example 4, Samantha invested $880 in an account paying an interest rate of 3.1% compounded continuously. There's the key word. So we want to use continuous compound formula. Assuming no deposits or withdrawals are made, how long would it take to the nearest tenth of a year for the value of the account to reach 1,270? Let's start with the initial amount. Times E raised to the rate, which we're going to convert to a decimal. Assuming we don't know how long it will take, so times time is equal to, we want it to reach 1,207. Okay, this one's pretty similar to the one we just got finished doing. We need to isolate the base and the exponent first. So divide both sides by 880. Okay, now we can convert to natural logarithms. So that would be L N base E and now we can use our calculator. The LN button is right here. Enter. So we have 0.3668. Now divide those sides by 0.031. So take this full answer in your calculator here, divide it by 0.031. To get 11.8, what are we rounding to here? To the nearest tenth of a year. So the 10th spot would be right there. Final answer, 11.8. Example 5, Brandon is going to invest in an account paying an interest rate of 5% compounded quarterly. So we will be using the compound interest formula here. How much would Brandon need to invest to the nearest dollar for the value of the account to reach $490 in 16 years? So this one is a little bit different from the ones we've done at this point, is that we don't know the initial investment amount. So I'm going to start with P times 1 plus, okay, the rate here is 5%, so 0.05. We are compounding quarterly, that'd be 4 times. Raised to the amount of times we're compounding times time, which they tell us is 16 years. And we're trying to solve for how much would we need to invest for us to get to $490. Here's what you're going to want to do first. Let's go ahead and simplify the parentheses and the exponent. So I'm going to plug that into my calculator. And we get this number, 2.21 something. Okay, now, how do we solve for P? What do you think? Divide both sides by that amount. Now, what you're going to want to do here is, you don't want to use the rounded portion yet. Let's just do 490 divided by Scroll up. Highlight the previous answer, hit enter once, then twice. It copies down the full thing. So we get 221.265. What are we rounding to here, for example, 5? To the nearest dollar. So if you round to the nearest dollar, we should get $221. That is what we would need to invest in order to get to $490, given the data they provided us with. Example 6, Alexander is going to invest in an account paying an interest rate of 2.4% compounded continuously. There's our key word, so we will be using continuous compound formula. How much would Alexander need to invest to the nearest $100 for the value of the account to reach $710 in 19 years? So this is very similar to the one we just got finished doing. Just using a different formula here. Okay, our rate times the amount of time, they say 19 years. And we want to accrue $710. Okay, here's what you could do here. We could just go ahead and divide both sides by E to our rate and our time, which I'm not going to write down again. I'm just going to wait and plug that portion into my calculator. So start with 710. Second ln brings up the base E, and then now our rate, which was 0.024 times the amount of time, which was 19. Hit enter. And we are rounding to the nearest $100. The nearest $100. This is the hundreds place. So our final answer here would be 500.